topic, which is hot, which is new fashion and no networks. No, let's say most, really most, like more than 70-80% of the networks worldwide nowadays use is the concept of virtualization and the virtual machines and virtual environments as well. This concept is simply before, like when you needed a server, you would buy a server. When you needed a computer, you would do that. When you needed to perform like multiple features, but each feature or each application or each service should be installed on a dedicated server, then you did that before, like by purchasing 4 different servers, 1, 2, 3, and 4. So these are 4 servers, and you needed to each one of them to give it an operating system. Each one of them is different from the other. You can do that, no problem. And then in order for all of them to communicate together and be able to reach your environment, you needed a switch to connect all of these. You needed power resource to connect to all of these to power them up to the power resource. Yes, it can be done in that way. And from that switch below, your network starts. And like one of them is called a DHCP server, a DNS server, an NTP server, and a syslog server. What are those? Well, all of these is actually explained in chapter 4. Don't worry. Like the name of the services, DHCP, DNS, syslog, etc., and NTP, all of them are even labbed, hands-on labs in chapter 4. We did that already. So the idea is 4 servers, a switch, etc., all of them, power consumption, redundancy, whatever. This is the old classic fashion. But if you think of that really, like one of the factors that you need to give attention to when you purchase like an expensive server, just for the sake of a DHCP services or DNS services, you will discover that you are wasting a lot of resources actually for that sake. This is number one. Number two, if for every single service you need a server, then you might have half of your data center filled with servers just for that sake, and they require so much power consumption, so much heat dissipation they need, etc., and that is not simple at all. And step number three will be also, or thing number three to mention, management. Yes, complexity of management for all of these servers, until the concept of virtualization came. And that concept says purchase one single server, this one, and take that server, and let's assume that it has 16 core. Let's say it has 16 core of the CPU, and it has like 64, let's say, gigabytes of RAM. Why not? Specifications and some whatever of hard disk drive like storage. And by using some virtualization stuff that are called hypervisors and an operating system or a software that can be installed, we can take this server and we can virtually split that server into 4 virtual servers. There will be actually called 4 virtual machines, and that's it, as simple as that. And it is, seriously, it is very simple, and I will tell you why, how simple is that, and I will even show you hands-on labs for that. Okay, so 4 virtual machines, each one of them will be called a virtual server, like virtual server 1, virtual server 2, virtual server 3, and virtual server 4. And using that hypervisor, which is an operating system, so you will purchase that server from the market. Step number 1. Step number 2, you will install a hypervisor on that server. It can be done in that way. Step number 3, the hypervisor will show a graphic user interface, looks like Microsoft Windows or something. Step number 4, start creating VMs, virtual machines, and assign virtual resources for them. So take the 16 core, split it on 4, and give 4 virtual cores to every VM. Take the 64 gigabytes of RAM, split it on 4, and give 16 gigabytes of RAM for every single VM. Take the 100 gigabytes of storage that you have, split it on 4, and give 25 gigabytes of RAM for every single VM. Eventually, in the end, at the end of the day, you'll have virtually 4 servers, and you will be able then to run each one of them separately, independently from the other, and to install an operating system like Microsoft Windows server or Mac or let's say Linux or Ubuntu or whatever on each one of them separately, independently from the other, and run whatever service you want on each one of them. Simply in 5 minutes, virtualization. No more. Virtualization. real hardware that can be used multiple usages at the time, that can contain multiple devices in it at the same time. The idea of virtualization, and that's it. This is what I wanted to tell you. So virtualization, again, is just networks, just like before, but in a virtualized environment, and multiple devices can be really inside one, and this will cause ease of management, like one single device. This can be managed, power consumption, heat dissipation, location in the data center, so many other things can be controlled as well by using the hypervisor, which is a mediator between the software and the hardware. Because before, you had to purchase a server and you had to install the Microsoft Windows Server software on that, the operating system on that hardware. Now things are different. You will buy the server, the hardware, you will install the hypervisor first, you will create virtual machines inside the hypervisor, you will log in and power up every single virtual machine, and then finally you will install an operating system like Ubuntu, Microsoft Windows, Linux, or whatever other one on that single virtual machine. Now 5 steps instead of 2 before. You will load the hypervisor on the physical hardware. After that, you will install the operating system on the VMs of the hypervisor. So now the hypervisor will be called names like a host, because it's hosting, and the operating system like Microsoft Windows will be called the operating system of a virtual machine, and sometimes the virtual machine will be called a guest. The hypervisor will schedule the virtual machine's request to the hardware, like the first VM requested resources, so the hypervisor will say, yes, I will give for you 4 cores and I will give you 16 gigabyte and you will use them, and when you're settled you will like shut down, etc. So the hypervisor will be responsible for that, because let me show you something from a side point of view. This will be your hardware, your server that contains the CPU and the RAM and the storage, and you will install the hypervisor on it. So the hypervisor will be the mediator, correct? And you will start creating multiple VMs on that virtual that hypervisor in that way. Yes. So when one of them requests something, or to communicate with the other through the hypervisor to the resources, and then up to the hypervisor, and then up to that, it will be done in that way. And also it distributes the hardware resources between the VMs. It's the one that assigns those resources. Okay, hypervisor types is extremely important because there are only 2 types of hypervisors in the world. Type 1 hypervisor is the hypervisor that I have been talking about for the past 7 minutes. The application the software that you purchase to install directly on your new server, and then you inside that hypervisor you create VMs, and for every single VM you assign resources, and after that you power up the VM independently and install an operating system for the VM. So this one is called the native hypervisor, or the bare metal hypervisor that runs directly on the hardware. So hardware, hypervisor, and then a VM, like Critics XCN and Oracle VM. Microsoft Hyper-V is the one most famous, and VMware ESXi is the one second famous as well. So these 2 are the most famous for type 1 hypervisors. Not for us, not to be installed on regular computers, no, for servers, and the CPU should support type 1 hypervisor, virtualization, etc. Things are done in that way. A type 2 hypervisor is called a hosted hypervisor. This one is not an operating system to install on the hardware. This one is an application or a software that has like 100 megabytes of size only, and you download that from the internet, and you double click that, and with a couple of nexts you install that on your computer, really, and you run it, and it looks like that. A type 2 hypervisor, everyone. This one is a hypervisor, and I can keep creating virtual machines inside it. Like this is a VM, this is a VM, and for every single VM I can type edit, and I can assign a RAM for that VM, a processor cores for that VM, storage, network interface card, etc. It can be done in that way. Yes, this one is called the VMware Workstation Player, which is a type 2 hypervisor. So this one is an application. Why would I use that? Well, I have Microsoft Windows on my computer, and I can use that to create VMs inside it. Each one of them, one is running Ubuntu, one is running Unix, Linux, etc. So that I will practice a study on there. And by the way, when you want to understand that even more, go to the tutorials playlist on my channel. There is a playlist called tutorials. There is something called EVNG installation. Watch the video, whether it was in English or Arabic, both of them are published, and understand the usage of a type 2 hypervisor, real usage for that. So it runs as a software beside your operating system, and you'll have your hardware. Upon the hardware, your Microsoft Windows, then you will install that hypervisor application, like the VMware workstation that I've just shown to you, and that virtual box. One last thing that I want to tell you today, something nice, which is the example of purchasing a very simple thing like a server from the market, and by using a type 1 hypervisor I have virtually created 4 virtual machines inside it. Now the question says, Sajjad, before, when things were real, like real 4 servers, we purchased a switch at that time, and the switch connected the 4 servers together and allowed them to connect also to my nodes, right? Right. What happens in the virtualized world? Like when I go to the room of the data center and I look for the servers, I find one server. Okay, it's one server. Well, the IT guy, the system administrator, says, no, it looks like one, but actually there are 4 servers inside it, 4 virtual servers. And I will say, okay, so this server is like representing 4 virtual servers actually. Yes, in that way, correct. How are they communicating? Sorry. Well, previously we needed a switch. Now we don't have a switch to do that, because this one single server is one server with no switches. And how are you connecting that to my network? Well, we can say like we can connect the Ethernet card or the Ethernet port of this physical server, the real server, to a real switch. But we are talking about VMs inside it. How can I bridge all of these there? By using a virtual switch. So a virtual switch is an internal virtual component that resides inside the device, inside the server, and this one does connect all of these together by virtually creating to them virtual network interface card, an NIC. This thing is the same card that you have in your motherboard of your desktop or laptop that contains the port, the Ethernet port that you connect your computer network to. So it will create virtual NICs for every single VM. It will virtually connect all of them to itself, to the virtual switch. Virtually have a switch inside the server, virtually have connections to it, and virtually this switch can also be bridged here, and it can be connected to your network. So this is an internal component for every single type 1 hypervisor. And that's it. It connects all the VMs together, and it assigns a virtual NIC for every VM. It exists by default for a type 1 hypervisor. After creating the virtual switch and the VNIC, all of the VMs will be automatically connected together in the same domain, and there are some options like isolating these in VLANs. What are VLANs? In chapter 2 I will tell you, and there is another one for connecting them to the internet as well. I will talk about that later perhaps, and that's it. Examples for a type 1 hypervisor, Hyper-V and ESXi. Both of these type 1 hypervisors does contain a virtual switch inside it. Before, I needed 3 videos, like an hour, to tell you the concept of virtualization. Today I was really like, I feel that it's enough just to tell you that in 14 minutes, and that's it. I did not skip anything important at all. If you were really curious about that, my Cisco CCNP in core course is already available on the channel in English language, and it does have chapter 2, which is called the virtualization chapter. Try to study the part of virtualization there, and you will understand much more info. If you're curious more, if you're more interested, you can do that there. And also you can go to the tutorial session, tutorial playlist, and you can see the EVNG video, which will give you a better image as well. Thanks a lot for reaching so far. The next video will be the final video of this chapter, and we will be done. Thank you.